I think we are live now. And I hear myself. That's great. Okay. So, hey everyone. Welcome to our next live coding session. My name is Attila Toth. I'm a developer advocate at Timescale. And today we are going to continue building our stock analysis tool with Python and TimescaleDB. Let me open my GitHub page for today's agenda. So first, if you haven't seen the other two streams that we did, I'm just gonna recap where we are right now, what we have, what we are hoping to accomplish. So let me get my drawing tool ready. So we're gonna do a quick recap. Then we are going to continue building this toolkit, and we're gonna analyze correlations between popular ticker symbols. Then we are going to look at the distribution of price changes, and then generate candlestick charts. And I'm going to be using Plotly, which is like a Python data visualization library. And also, finally, I will show a very powerful feature of TimescaleDB, which is continuous aggregates, how they work. And we are going to set up a new continuous aggregates view for one of our stock data visualization tasks. So let me know if the audio is good, the screen is good. For this stream, I set a lower bitrate because I heard for some people it was laggy on their end. But as I see, everything is good. All right, so let's look at the code, what we did until now. So basically, I'm using Python, and I'm using a finance API from 𝗙𝗶𝗱 𝗀𝗏. And at this point, we created two Python scripts. One is responsible to fetch data from the finance API. We called it stock analysis, and the other 𝗥𝗲𝗀 that's doing all the visualization stuff and all the exciting analysis stuff. And we also have a Jupyter notebook here because it's just easier to analyze some of the data we have with a Jupyter notebook. So I don't want to dig deep here. What we were doing here in this stock analysis script, just to give a quick overview. So first, we are gathering ticker symbols from a website. Actually, we scrape it. This is how we get the symbols. Then we are iterating over each ticker symbol, and what we're doing is fetching their intraday price points from the past, in this case, last 6 months, but we could also do the last 2 years because we also have that data available from the API. And we're fetching it, and we are inserting this data set into a TimescaleDB instance. I'm using a managed version of TimescaleDB, TimescaleDB Forge, because that's the easiest way to get to use TimescaleDB. So that's what this script does. And then we have the explore script, which basically just has a bunch of queries and visualization code. And we worked on this file last time, and we can quickly go through some of the visualization stuff we did last time. So I'm using Plotly as a library, mainly because I think it's just really easy to use. It has a really high level API, which I really like, as opposed to, for example, Matplotlib, where creating a very simple chart takes relatively a good amount of code. And with Plotly, for example, just a simple line chart is literally just one line of code. So it's pretty cool. So let's go through these visualizations. So last time the question was that we wanted to answer with data is how insert ticker symbol price changed over time. So for example, how Apple's price, stock price, changed over time. And we came up with this query, which basically uses a few TimescaleDB specific feature. For example, the time bucket feature, which is really useful. It's basically a more powerful version of Postgres date trunk function. It lets you it lets you group time. It lets you group your records based on time, but you can do not just one day. You can also do like 1 hour, or you can also do for whatever you want, really, 12 hours or whatever you need to do for your query. So it's really flexible. And then we also used last, which is an aggregate function in TimescaleDB. It basically selects the last record in the specified time bucket. And then we used we queried the database, we put the result into a data frame, and we passed the data frame to Plotly, which generated this line chart. So that was our first query, and then we did a very similar query, but this time we were interested in trading volume. Then we generated a bar chart. This bar chart has the symbols with the most transaction volumes in the last 14 days. Also, one interesting thing we did, because in our database, we only store, well, in our table, we only store the symbols. So this is our table, which has all the price information. We only store the symbols, but we also have another table here called ticker, which actually has not just the symbol but the name. And this one is just a regular Postgres table. And what's really cool is that if you're using TimescaleDB, you can just join this regular Postgres table with your time series table, which is stocks new in our case. And because of this, you can have the name of the company, so not just the symbol, which is pretty good. And then we did FANG prices over time on a line chart, and then finally, this is the last thing we did, which symbols had the biggest daily gain and loss. And for this, we just had the results in a data frame. And so building on this, one thing I noticed the last time, especially with this chart, is that it would be much better to basically generate this exact same chart, but not with price points, because currently, if you look at the y-axis, we have 500,000, 1,500, and so on. Because these values represent the prices, but in order to really be able to easily compare stock prices, I think it might be better to compare the price changes and compare the percentage values between stock prices. So that's why I came up with the so that's what we are going to do as a second step to have an easier way to see correlation between symbols. So basically, let's try to reuse one of the previous queries where we have percentage. So in this query, we have price change percentage, which is basically what we need. Like it returns the change of the price as a percentage value. So let's just try it in 𝗙𝗶𝗺. So we go create a new SQL script. So if we run this, it's a lot of data, so it's taking a little bit. So this returns the percentage values for each symbol. We limited the rows to 5, so we only see 5. So basically want to have this query for specific symbols. So let's say we want to do let's say we want to do symbol equals let's do Apple, because that's like one of the most popular stocks. So let's do Apple, and let's do maybe Facebook. And we can do basically create a list. So if symbol is in this list, and we don't want to limit the results because we need all the records, and the comma. So now basically what we have is let me hit an enter here, because it's actually a sub query. Yeah, so basically we have this subquery here where I have a time bucket set for 1 day. So basically now we have the daily price changes for Facebook and Apple. And this might be better to compare for comparison purposes than if we were to use this chart, because it has price points and not percentages. So now let's see how we could so basically we have the data frame with this query. So let's go to our Jupyter notebook. This is going to be the query. Let's create the data frame. Read SQL. So we have the data frame, and let's create the chart with Plotly, and we need a line chart. So that's gonna be px.line. Px is let me run this part of the code again. So px is basically a Plotly Express module, which has the kind of high-level API that we're using. So we are using px.line, and we need a data frame. We need to define what should be on the x axis, and so on the x axis we need the date time, or the dates, which is in this query time frame. And then on the y axis, we will need the percentages, which is price change PCT. So let's try this and see if it does what we need. Figure show. So if you run this, we need a connection object for read SQL, which is just con. Okay, so we have an interesting result here. I think the problem is that if we go back to dbVer, so we have price change percentage, and basically that's a difference divided by the closing price times 100. So this times 100, I don't think we need that, because Plotly is expecting a float value, I suppose. So let's try it without times 100. Also, let's just first try to do it for one symbol. So if we do this, we don't have anything. All right. Yeah, because we are just querying one symbol. So let's do this instead. No. All right. Oh, because Apple has a different symbol. Yeah. Okay, so it's AAPL. AAPL. But it still looks really weird. So basically, we have the price change value. We select this in the subquery. We have symbol, the time bucket. Let's do 7-day, so we have less data points. Time frame, we have the first, which is the opening price, last, which is the closing price, right? We are grouping by this. Okay. What if I do color and say symbol, even though we just have one symbol? So that shouldn't be the problem. Actually, let's try. So I said Plotly is expecting percentage, like float values, but I don't think it's actually true. So if you do, so let's look at the Plotly docs. So we need line. So basically, we need to say that the y-axis is percentage, and I think there is a there's an update layout function in Plotly. Update layout where you can do this kind of thing. Anyway, I will try it because I remember there is a parameter called y-axis, and you need to define a dictionary for the ticks. Something like this. And if you want like two double yeah, something like this. Interesting. So if let's go back to dbeaver. So if I go here, I have, so for this one, I have Apple and Facebook. Okay, interesting. What was the problem? Oh, did I query the wrong table? I think I did. I think I should query stocks new too. No. Anyway, so basically, I think, yeah, so we have percentages here, which is good. So if I just times 100, it should screw this whole thing up. Yeah, that's what I expected. So let's just do this. Okay, so basically here we have Apple and Facebook. Let's add some other ones as well. Where is my ticker table? So let's maybe add Amazon. Let's add maybe Microsoft. Okay, so we are currently querying in 7-day buckets. And this is the full database, which means the last 6 months and a little bit more, but around 6 months. So let's do, well, we can zoom in and we can already see, like, even if it's like it's 7-day buckets, but it's still, you can see some kind of correlation. What if we do 1 day? Let's zoom in. Okay, this is actually harder to see. Let's go with a larger bucket. Let's do 2 weeks, which is 14 days. Okay, so what we see is that they are pretty correlated. They are following each other when it comes to changes in a 14-day time windows. All right. I will see after the stream why the previous query did not work, because that should have, yep. Mm-hmm. Yeah. Yeah, because I started off by basically trying to modify this query. And I order here. I'm not sure. Uh, so I say where Apple. Mhm. Hmm. Hmm. Right. Right. Yeah. I missed it too. Because for this one, we needed the biggest price change. But for yeah. Oh, not this one. Oh yeah. Yeah, cool. All right. So let's see what was the other um yeah, so this was correlation between popular symbols. Maybe we could yeah, so we basically looked at let's look at the fang symbols as well, just to um do that as well. So I have the fang symbols here. Okay, so this is a little crowded. Let's try to zoom in. So one thing is Netflix looks to be much more volatile than others. Netflix has these 10% price changes in a day. But other than that, they seem to be somewhat correlated. All right, let's move on. Let's see distribution of price changes in a given time period. For this, I'm gonna be using some kind of a scatter plot, and I think we will need to use the same or at least a similar subquery as before. So I'm just gonna copy paste it. Let's go to 𝗙𝗶𝗱. So we have this query working. And basically we just need, I'm wondering if we need to change anything for the distribution to generate basically a scatter plot. So plotly scatter plot. So it just, we need a data frame, we need scatter, and to define the X and Y axis. All right, let's try to do that. So I have this query. Oops. So I have this query. I read the data into a data frame, create a new figure, scatter. It needs the data frame. It needs the X values or the name of the column in the data frame, which is well, depends on what we want to do. So distribution of price changes. So if we want to see basically distribution of the percentages, then I will need the percentage values, which is price change PCT. And for the Y axis, in the example, they have another column for the Y axis, but I don't really have another column here. I just basically wanna like count the different percentage values. So if I don't define a Y axis, I think it should work. And let's do the same percentage formatting thing as we did before. Oh, and I need to show it. Show. Okay, so basically, yeah, actually the percentage values are on the X axis, not on the Y. Right? Yeah. So basically we're using the same query as before, which returns the, let's go back to 𝗙𝗶𝗱. So which returns just the daily price changes in percentage for the FANG stocks. And we are showing it on a scatter plot. And it looks like if I don't define anything as a Y value for Plotly, it knows what it needs to do, which is basically just count the number of percentage values. Now one problem is, so we can let's just do it for one stock, but I think we can do the same coloring as we did before. Okay, so this is Apple, and basically each point represents a day, or well, a price change during that day. So it's basically most of the changes are happening between -4% and +4%. Now I suppose if I change the time bucket to something bigger, it should be more spreaded. Yeah. We can even see -11.48% and +9%. What if we do 1 min? which is the most granular that we can go. It might take a while because it's a lot of data. Interesting. So we have most of the, well, it's just 1 minute. So in a minute, we cannot really expect a big change, even though there is some, this one is 3.58%, but most of them are really between 0 and 0.56%. All right, let's compare the daily. Yeah, let's do daily changes, and let's compare Apple and let's do Facebook. And let's also add a color parameter, so they have different colors. Okay, it's not color parameter. Oh, it's for the scatter, not for the update layout function. Okay, so basically Apple is blue, Facebook is red. They're pretty similar. Let's do 7-day. Pretty similar. Let's put zoom on this chart, because I remember from last time Zoom had some interesting days, really volatile days. So if we have zoom in there, yeah, so basically blue and the red dots are Apple and Facebook. The green dots are Zoom, and this is daily changes. So basically Zoom is more spreaded, I suppose. That's how you say it. It's like there are days with 13% change. This one is 17%. So Zoom is definitely more volatile. What if we do, let's select another ticker. Let's do 3M, because I'm guessing that might be more boring than Zoom, for example. Yeah, so now, so the green one is 3M. And let's remove Facebook and Apple so it's less crowded. Okay, so basically we have in the middle 3M and Zoom with much bigger daily price changes. What if we do 14-day? Yeah, it's still visible that Zoom is more volatile. All right. Now let's do candlestick charts, especially because our data set is in 1 minute intervals. So we can draw some interesting candle charts. So for candle charts, we will need, let's go to 𝗙𝗶𝗱 first. We will need, well, actually, let's check the Plotly documentation. So we're looking for candlestick charts. And they actually have a stock example here as well. So basically we'll need the Go module. So let's import that. And we'll need to do something like this. Read SQL. So we will definitely need to do, we need to use time bucket once again. And let's use let's use 15-minute to see 15-minute candlesticks. It's stock date time. And for the candlesticks, we will need yes, we will need the opening price, highest price, lowest price, and close price. But because of the time bucket, we need to use first and last. So for price open, let's select the first opening price in each bucket. As price open. For closing price, we pretty much need to do the same thing except it's last. And price close. And then for the highest price, so in these buckets, we're gonna have multiple values for price high. I think it's called price high. Yeah, price high. And we want the highest value of those of that column. So let's use max as price high. And for the lowest one, I need min. Right. Stocks new 2. So if I do this, this will return a bunch of, I need to group by, right? So this will return a bunch of time buckets, right? And we have the price open, price close, price high, price low for each one. Okay, I think this is all what we need. We can have a filter on to just see let's say let's not use Apple, let's use another one. Let's do Tesla. Okay, so these are the Tesla numbers. And these should be the candlestick values. So I think our query should be good. So I paste the query here, and for the chart, do we have data? Yeah, we have the date time as time frame. Open is price open. Price close, that's this one. Price high is this one. Price low is this one. Now 15-minute intervals. So let's add another filter because this is going to be a lot of data. So let's maybe let's only select data from maybe after June or after May. So 2021 May 1st. Okay. So if I run this, let's see if it works. This is still a lot of data for Plotly, but let's see if it does something. The query is pretty fast, so yeah. Oh, sorry, I didn't show it right. Okay, now it should be good. Okay. Yeah, so my notebook is freezing a little bit because it's a lot of data, but we can zoom in. So let's zoom in. Okay, let's try less data because it's laggy. Not because of TimescaleDB, just because of Plotly and because I'm using Jupyter Notebooks. So let's try after June. And well, we are requesting like data in 15-minute intervals. So let's try after June. Should be faster. Okay, so let's zoom in. Let's say this period. Let's actually, it might make more sense to just request one day because we are looking at minute interval data. So let's just do stock date time equals let's try June 23. If we have data from that day, I think we do. No, we don't. All right, then let's try June 15. Okay, so we have June 15, and this is a candlestick chart for Tesla. and each candle is a 15-minute interval. So we have 9:30, 9:45, 10. We can zoom in, we can zoom out. So this is pretty cool that Plotly can do this. All right, let's see. What if we do 1 minute intervals? Yeah. So these are really small candles because there is not much change happening in a minute. Let's do 1 hour. The red ones are when the stock price was falling, and green ones are the ones where the stock price increased. All right, let's try another ticker, and then we're gonna do continuous aggregates. Let's try Zoom. Zoom is always interesting because they have volatile days. So let's try Zoom. Okay, so this is June 15. An hour intervals. We can do 15-minute intervals. Okay, so if we zoom here, so 9:30, opening price was 364, closing price 360. All right, so I actually really like Plotly because it's really easy to generate these kind of charts. If you figure out the query, then basically you don't need to spend any time on figuring out the chart. Cool. Now let's try continuous aggregates, because basically continuous aggregates could be really helpful or useful in some situations when dealing with stock data or really any other kind of time series data. Like for example, if we go back to so if we go back to, let's say, this query, we used this subquery, which is basically just creating these time buckets and figures out the opening price and the closing price. But we needed to use this query, subquery in multiple queries. And continuous aggregates can be helpful for situations like this. So basically, let me just quickly open the TimescaleDB docs if you are not familiar with continuous aggregates. So basically, continuous aggregates are really similar to Postgres materials view. The difference is that materials, when you create a Postgres materials view, you actually create like a new like you actually create the data for the view, and when you need to refresh that view, you need to refresh or update something in that view, you need to drop the materials view and create a new materials view, or if you don't need to do it, the database itself does it for you. But with big queries and when dealing with a lot of data, it takes a lot of resource to do it. So basically, continuous aggregates, they when you need to refresh the data, they don't recreate the materials view. They can just select that portion of the records which actually need updating, and they just update those records. So they so it takes much less resource. Is that right, Ryan? I don't know if you're here, but feel free to jump in if you want to correct what I said. And I was just talking about continuous aggregates and what is the difference between Postgres materials view and TimescaleDB's continuous aggregates.
That a materialized view, every time it's quote unquote refreshed, that's a function in Postgres, it recreates the table all over again, given whatever time range you have, and then kind of does that, swap out at the end. So it replaces what was there with the thing it just created. So you always lose all of your data, which means if, for instance, your raw data that you're aggregating was, you refresh it this week and you refresh it again next week, and you had some hypertable data that had been removed for some reason, you now lose that aggregate. And then that also, like you said, it's much more intensive to refresh. With continuous aggregates, it is its own, because it's chunked, it is actually a form of a hypertable. So it's chunked just like a hypertable, and we can very succinctly just update the little slices of time that any data has changed, whether it's new or updated data. So we're not dropping the whole thing on every refresh, right? We're only updating what needs to be updated. So you can actually keep that data for a much longer period of time, which is pretty cool.
Right. So let's turn this query into a continuous aggregate. So basically, it's very similar how you create like a simple like a Postgres materials view, but you need to use TimescaleDB, obviously. So let's create materials view. And let's say we want to get the candlestick data for Zoom every day. So let's call it candle ZM daily. And then we need to with a TimescaleDB and the query itself, which is this one. And if we want to get the, I'm wondering if well, we want the last day in the continuous aggregate, but But let's just select all the data after, I don't know, let's do March.
Yes, that's a really interesting point, because a lot of people ask this, you know, how can I do a continuous aggregate that only starts at some period in time, right? And because of the refresh policies, you know, they want to be able to go back and refresh a month, but they don't want, you know, some particular set of data. So you can, you know, your continuous aggregate query can have a date in it, right? And so it doesn't matter if we try and refresh the end result. If you were to try and refresh January, you're not going to get data for January because it's, you know, it doesn't satisfy the query. So that's one way to do it, which is pretty cool.
Also, after this, we can we need to set the a policy to refresh the this view. So basically, we have fresh data from the last day as well. So if I create this, oh, I'm using that's not a hypertable. Oh yeah, because stock's new. That's a hypertable. Okay. So this created the materials view. I have a lot of views here, but let's find candlestick daily. So this is our view, and currently we can query this, but to actually make it refresh and get updates daily, we can set up a policy for this. Adding automatic refresh policy, which basically has, so obviously you need to define the name of the view, the start offset, which is the beginning or the start date where you would like to you know, get the updates, and the end offset is the end date where you would like to update your data set, if that makes sense. A schedule interval is how often or when do you want to execute this refresh policy. So our view is called candlestick daily. Start offset. Let's define an interval. So maybe we could do 2 days as the start offset, and then the end offset is 1 day. So this will give us, this will update the view with last day's data. And we can also check all the policies in the TimescaleDB information views. If we go, well, in continuous aggregates, you can see all the views that are currently, or all the continuous aggregates views that you have. We have candlestick daily here. And also you can see the related data in the jobs view. And the last thing I wanted to show is that, so currently it will refresh every day and it will update the view every day. But if you want to refresh it manually, you can also do that by calling the refresh continuous aggregate function. And you can also pass 2 parameters there as the refreshing interval. So you can do that as well. All right, so basically, I think that was it for this stream. We were able to do more analysis on our data set, and basically we can do at this point pretty interesting visualizations with candlestick charts, and you know, comparing different symbols, distribution. So yeah, anyway, thank you for watching. Also, if you're watching this on YouTube, there are links in the description for this GitHub project. We put all the code of this project to GitHub. Also, we have usage instructions, so you can just clone the repo, install the requirements, set up your database. We have all the scripts in the repo, and you can start analyzing stocks data yourself. You can also modify all the scripts. We have a SQL script folder and an explore script with all the queries that I'm running. So you can just, you know, change it up and try something new, something interesting. And yeah, that was it. Thanks, Ryan, for the help and for the support. And see you hopefully next week.